Hi, in this video, we're going to look at how we go about tackling exponential equations where single terms have more than one exponent. Now, in previous videos, we have said that if the bases are the same, the exponents will be equal. In a previous example, we looked at a to the power of x is equal to a squared and found that x is equal to 2 because both terms have a base of a. Now, as long as the bases are the same, the exponents will be equal regardless of how many exponents each term has. Here we have a to the power of x plus 1 is equal to a to the power of 4. A is our base on both sides, which means that our exponents are equal. From this, we can see that x plus 1 is equal to 4. Now we can solve for x. Let's subtract 1 from both sides, and we see that x is equal to 3. Using this idea, let's look at some examples. 2 to the power of x plus 1 is equal to 2 to the power of 3, with a base of 2 and a base of 2, which means our exponents are equal. So we can say x plus 1 is equal to 3. To get x by itself, let's subtract 1 from both sides, and we see that x is equal to 2. Let's do another example. 1 over 3 with an exponent of x minus 2 is equal to 81. We don't like fractions, so let's change 1 over 3 to 3 to the power of negative 1. Let's put into a bracket, and we have an exponent of x minus 2. We have a 3, and we know that 81 has a prime base of 3 and an exponent of 4. Our next step is to multiply out these exponents. So we have a base of 3. Negative 1 multiplied by x is negative x. And negative 1 multiplied by negative 2 gives us positive 2. And on the right, we have a base of 3 and an exponent of 4. Now we have a base of 3 and a base of 3, which means our exponents are equal. So we have negative x plus 2. So over here, I'm going to say negative x plus 2. And on the side, we have an exponent of 4. So we can say equal to 4. Now we can solve for x. X is negative, so we're going to move it to this side of the equal sign. We have a 2 over here, so let's leave 2 where it is. And we're going to move our 4 across, so we say minus 4. Now we have 2 minus 4, which is negative 2. And we can see that this is equal to x. Let's do another example. 5 to the power of 3x is equal to 25 to the power of x plus 1. 5 is a prime number, so we can say 5 to the power of 3x. 25 is a prime base of 5 and an exponent of 2. And we still have an exponent of x plus 1. Now we can multiply out our exponents. So we have 5 to the power of 3x is equal to our base of 5. Then we multiply 2 by x, and we get 2x. Then we can multiply 2 by 1, and we get positive 2. Now we have a base of 5 and a base of 5, which means our exponents are equal. We can say 3x is equal to 2x plus 2. Let's get our x values by themselves. So we're going to move this 2x across. 3x minus 2x is x, and we see that it is equal to 2. Let's do another one. 8 to the power of 3x minus 4 is equal to 4 to the power of 2x. Let's start by changing 8 and 4 into their prime bases. We know that 8 has a prime base of 2 and an exponent of 3. and then we have an exponent of 3x minus 4. 4 also has a prime base of 2, an exponent of 2 as well. And we still have an exponent of 2x. Now we can multiply out our exponents. So we have a base of 2, 3 multiplied by 3x is 9x, and 3 multiplied by negative 4 is negative 12. It's equal to, on the right, we've got a base of 2. 2 multiplied by 2x is 4x. Now we have a base of 2 and a base of 2, which means our exponents are equal. On the left, our exponents are 9x minus 12. And on the right, we have an exponent of 4x. And now we can solve for x. On the left, we have 9x. So I'm going to write it over here. Let's move this 4x across. So we say minus 4x is equal to, we have negative 12. We're going to move it across and becomes positive 12 on the right-hand side. 9x minus 4x is 5x, and that is equal to 12. To get x by itself, let's divide both sides by 5, and we see that x is equal to 12 over 5. I want to do one more example. 2 to the power of 2x minus 1 is equal to 0,5. Now, decimals are difficult to work with. So the first thing we need to do is to change this decimal into a fraction. So on the left, we have 2 to the power of 2x minus 1. And we can rewrite 0,5 as 1 over 2. But fractions aren't that easy either. So let's change this 2 over here. So on the left, I have 2 to the power of 2x minus 1. And on the right, 1 over 2 becomes 2 to the power of negative 1. Now I have a base of 2 and a base of 2, which means our exponents are equal. So I can say 2x minus 1 is equal to negative 1. Let's leave 2x where it is and move this negative 1 across. Negative 1 plus 1 gives me 0. Divide both sides by 2, and we see that x is equal to 0. Please work through some exercises in this section before continuing with these videos.